Okay, we're going to cover section 3.3 in our BJU Press Algebra 2 textbook. We're going to take a look at graphing lines. So the first thing I want to introduce you to is what's called the slope-intercept form of a linear function. So this is in the form y equals mx plus b, where y is completely solved for, x has a value next to it, and then you have a constant term by itself, the b value. So the m, or the number that appears in front of your x variable, is what we consider the slope of our line. The b value, which is the constant number by itself, is what we call the y-intercept. And remember, y-intercept is a point. It's when x is equal to 0, because if you think about it, if you were to let x be 0, 0 times whatever number this is just 0. So that means your y would be whatever your b is. So your y-intercept is going to be 0, because that's what we're letting x be, comma, and then whatever your b value is. And the y-intercept is where, if you were to sketch your graph on a coordinate plane, where is it crossing the y-axis at? What point? And so that's why your y-intercept will always be a point. And the b tells us the y value of that point. So it's always going to be 0, comma, and then that b value. So let's do some examples of just identifying slopes and y-intercepts. So for this equation, our slope would be 1/3, and our y-intercept is not going to be 4, it's going to be 0, 4, because remember, the y-intercept is when we let x be 0, so 0 times 1/3 is 0, and 0 plus 4 is 4. So we get 0 for our x-coordinate, and 4, which is what we get when we let x be 0, which is our constant term, the b value, 4. So for this one, our slope is -5, and our y-intercept is 0, 4. This one, our slope is 3/4, and this time our y-intercept is going to be negative because our b value is negative because it's -7. All right, so all of those linear functions were very nice, and they had already solved for y for us. They had already been in slope-intercept form, y equals mx plus b. Sometimes you're going to get equations that are not in that form, and you have to change them by manipulating the equation. So the first step is going to be to solve for y. Then we want to arrange the terms on the right-hand side so the x term appears first, so we can identify the m and the b. So let's do this example. We have 3x plus y equals 2. So we want to solve for y. So the first thing we are going to do is subtract 3x from both sides. So now we have y equals 2 minus 3x. Now we want to rearrange the right-hand side. So we'll put the -3x in front. So -3x plus 2. Now we can do our slope and our y-intercept. Our slope is -3 and our y-intercept is 0, 2. Let's do another one. So solve for y. So first we are going to subtract x from both sides. So we have -2y equals 6 minus x. We haven't quite solved for y yet, so we're going to divide everything by -2. 6 divided by -2 is -3. Negative x divided by -2 is going to be positive because it's a negative divided by negative. It's going to be positive x over 2, which is the same as saying 1/2 x. So we'll arrange the right-hand side so our x term comes first. So now we have 1/2 x minus 3. So we can identify our slope and our y-intercept. Slope is 1/2 and our y-intercept is 0, -3. Go ahead and try this one on your own. Okay, you should have gotten option 4 because if you subtracted x from both sides, you would have gotten -y equals -x minus 1. But then you would have to divide everything by -1, which means everything's going to turn positive. So you'll get y equals x plus 1. So let's discuss slope now. Slope is a steepness of a... So in order to get a slope, you're going to look at the change in the y values over the change in the x values. So change in y over change in x. So the difference in the y's over the difference in the x's. We also consider this rise over run, which when we're looking at graphing lines is very useful to us. We also have this formula here, the y2 minus y1 over x2 minus x1. And that's a useful formula for calculating just if you're given 2 points and you can think about, I need to know what is the difference in the y values and then what is the difference in the x values. So let's look at this one. We have a line. It looks like it's a positive slope because it's going upwards. And so if we want to know what the slope is, remember we're looking at rise over run. So the ratio of the vertical change over the horizontal change. So pick 2 points on the graph. Let's pick this point and this point. Okay, so we have this point and this point. So what was the vertical change? We only had to go up 1 to get from here to here. So our vertical change is 1. Our horizontal change is also 1. So if our vertical change is 1 and our horizontal change is 1, then we have our slope is 1 over 1, which is just 1. Now, if I had an equation and I knew that my y-intercept was 0, 1, I could plot that 0, 1 and then use my slope to graph different points. I could go 1 over 1 and then a 1 over 1 again and then 1 over 1 again and keep plotting points and then connect those points to graph my line. Let's look at this slope. This slope is negative. So when we calculate this slope, we need to make sure we put a negative in front of it because it is going down. So find 2 points on this graph that are kind of easy to locate so that way we can see their values. So here is 1 point here. We'll do our y-intercept. This is 1, 2, 3, 4. So we know that our y-intercept, or the b value for this equation, if we were to write an equation, we know that our b value would be 4, right? So let's see the vertical change over the horizontal change. I'm going to choose this point to be my second point. So vertically, I only had to go down 1. So if I'm going down, there's my negative. That's another way I know this is going to be a negative slope. So I had to go down 1, so that's my change in my vertical. Horizontally, though, I had to go 2. So my vertical change is 1, my horizontal change is 2. So that means my ratio is 1 over 2, or 1/2. So my slope is negative, because it's had to go down, negative 1/2. So go ahead and see if you can tell the slope of this line by yourself. So you should have gotten 3 over 2. It is positive because it's going upwards. If you were to pick 2 points, so let's pick this one and this one. Vertically, you had to go up 1, 2, 3. So that's where the 3 came from. And then you had to go over 2, and that's the horizontal. So we were looking at the graph, but remember you can also calculate just by points. Remember, it's the change in the y over the change in the x. So change in y, 1 minus 5 is negative 4. And then negative 4 minus 1 is negative 5. So you have 2 negatives, which means you end up having a positive, which means our final answer is going to be 4 over 5. So let's look at this one. So again, change in y over change in x. x, right? So before I did the first numbers minus the second numbers. You can actually do it the other way, as long as if I choose to do 8 minus 3, when I calculate my vertical change, I need to make sure I do 2 minus 1 when I calculate my change in my x. So 8 minus 3 is 5. That's my y change, or my vertical change, which is my numerator. And then 2 minus 1 is 1. So that is my change in my x, or my horizontal change. So I have 5 over 1, which is just 5. So my slope is 5. Okay, let's do this one. So 7, I'm going to go this way again. 7 minus 3 is 4. And then 5 minus negative 2. 5 minus negative 2 is actually 5 plus 2, which is 7. So I end up with 4 over 7 as my slope. Go ahead and try this one on your own. So 10 minus 4 is going to be 6, and 3 minus negative 1 would be 3 plus 1, which is 4. So you have 6 over 4. And none of these answers are 6 over 4. However, 6 over 4 is a fraction that could be reduced. 6 over 4 reduces to 3 over 2. Let's try this one. So 5 minus 5 is 0, and 6 minus 3 is 3. So 0 over 3 is the same as saying 0 divided by 3, which is just 0. All right, so graphing lines. The first thing you want to do is put into slope-intercept form, because if you put it into slope-intercept form, then you can plot the slope-intercept. And then once you graph or plot your y-intercept on your coordinate plane, you can use the slope to move to the next point. So I want to point out some special types of lines. We have what are called horizontal lines, and that's where all the y values are always going to be the same. The slope is going to be 0. So if the slope is 0, that means if you're looking at your function, you're not going to have your x variable. Because remember, slope appears right in front of your x variable. So if your slope is 0, you have 0 times x, which is just 0. So your equation is going to look like y equals a number, right? And so it's going to be a horizontal line. And no matter what value you plug in for x, your y value is always going to be that y-intercept. Vertical lines, all the x values are going to be the same. And the slope is going to be undefined. And the reason it's undefined is because you have no change in your horizontal, because it's a vertical line. It doesn't go left to right. And so because there's no change, remember, slope is vertical change over horizontal change. Well, if you have no horizontal change, you cannot divide by 0. That's undefined. So you can also use your calculator to see a graph of a line. You would want to go to y equals, and once you do that, you will see a screen that says y1 equals. And when you can plug in your equation. If you plug in your equation and hit graph, it will graph the line for you. So you can actually look at several graphs at the same time. If you notice that there's on that y equals screen, there's y1 equals, y2 equals, y3 equals, y4 equals. So you can compare them as well. So let's go ahead and graph y equals 2x plus 3 on your calculator. And then at the same time, in y2, put y equals 2x minus 7. And go ahead and look and see if you can tell how are those lines related to each other if you were to look on your graph. You should have noticed that those two lines had the same, they were parallel, right? They were parallel lines if you were to look at the graph. And if you notice, their slopes were the same. So now let's try these. Do 2x plus 3 and compare it to negative 1/2 x plus 7. So if you notice, these lines, if you were to relate them to each other, these lines are perpendicular to each other. They meet at a 90-degree angle. So now my next question is before when we were looking at parallel lines, the slope were the same. These slopes aren't the same to a negative 1/2. However, they are related to each other. So the reason they're related is 1/2 is the reciprocal of 2, but you also have a negative. So how are they related? They're negative reciprocals, or negative flips of each other. All right, so let's recap those last couple of slides about parallel and perpendicular lines. So parallel lines have the same slope, whereas perpendicular lines, their slopes are related because they are negative or opposite reciprocals. So whatever one slope is, you flip it or take the reciprocal and you do the opposite. So if your original slope was negative, you make it positive. If your original slope was positive, you make it a negative. And then as well as taking the reciprocal of it. So that's all for this lesson. Go ahead and try your problems.